Okay, welcome. This is your notes for 3.6 Cramer's rule. The first part of these notes is going to be going over what is Cramer's rule as well as how to calculate the determinant. So first off, Cramer's rule states that well, first off, it's a method for solving systems of linear equations where we use determinants. A determinant. Okay, in the notes I have it highlighted as to what's important, but a determinant is a scalar value computed from the entries of a square matrix. This provides information about the properties of the matrix and the linear transformation it represents. If you're given a matrix A, the determinant of A is just a single number, okay? And we'll denote it as det A or what looks like absolute value of A, but just don't confuse it with the absolute value. It's just another way to indicate or another way to annotate or notate something here to note it. Okay, so Cramer's rule, like I said, it's a method for solving systems of linear equations. We're going to be using determinants. It is a clean formula-based method for finding values for each unknown in a system, which works if and only if the system is a square system. And so what is a square system? That just simply means the same number of equations as variables. So if you have two equations and two variables, you have a square system, or three equations, three variables. Okay, those are square systems. Now, if you have two equations and four variables, it is not a square system. The other condition is that the determinant of the coefficients is non-zero. Okay, and that'll be more self-explanatory when we get into the what is the actual Cramer's rule. So Cramer's rule says this: given a matrix A is equal to, and so here I have this generic matrix A, B, C, D as the coefficients, J and K as the constants. The solutions can be found as X is equal to the determinant of the X solution, so that's the blue component here, divided by the determinant of the coefficients. And the solution for Y can be found by taking the determinant of the Y solution divided by the determinant of the coefficients. So what exactly is the determinant and how do we calculate it? So let's just take something basic for now. We have finding the determinant of the square matrix for a 2 by 2 is all we're going to focus on right now. We have A is equal to the matrix A, B, C, D. The determinant of the coefficients, or in this case here, the determinant of A is we're going to take the A, B, C, D component. We're going to put A and C in blue here, and then we're going to take B and D in red. So we have our two components. The X components right now is A and C. The Y components is B and D. So to calculate the determinant, what you do is you take the first cross product of A times D. So we're going to take A, we're going to multiply it by D. And then what we're going to do is we're going to subtract the product of C times B. So C times B. Now, there are two things that this is going to tell us. If your determinant of A is not zero, that means there is exactly one unique solution and the matrix is invertible. And when we talk about invertible, that means it's how we can undo the matrix. We can use it to solve later on. If your determinant is zero, there is not one unique solution, meaning either the system has no solutions or there's infinitely many solutions. And so this comes back to the formula. If you're dividing by the determinant of A and your determinant of A is zero, you cannot divide by zero, so therefore there would not be a solution that we're going to find or a single solution. So let's go through some quick practices here. Here I've got four matrices. A, we're going to focus on the first one. A is the determinant, or A is equal to -6, -8, 2, 9. So the determinant of A, so let's take this, we're going to do this in purple here. So the determinant of A is the cross product of -6 times 9 minus the cross product of 2 times -8. Okay, and this is going to give us -54 plus 16, which is going to give us negative 38. So this determinant is going to tell us if these were the coefficients, this would be a one solution. But for now, we're just going to focus on calculating the determinant here. Okay, second one, B. B is 10, 0, negative 10, 10. So we're going to take the determinant of B. We're going to do the cross product of 10 times 10. And then we're going to subtract the other cross product of negative 10 times 0. Which is just simply 100 minus or plus 0 in this case. Which is just 100. Okay, matrix C. We're going to find the determinant, so we're going to take the determinant of C. We're going to do the cross product of 9 times 9. We're going to subtract the cross product of 12 times 3. So this is going to be 81 minus 36. And this is going to give us 45. Okay, the last example is D. The determinant of D is 2 times 2 minus 1 times 4, which is 4 minus 4, which gives us 0. And so that is how you calculate the determinant of a square matrix.